Today I'll be taking a look inside this multi-port USB charger. It has 5 outputs and a power input on the side. It is rated for 100 to 240 volts AC input and outputs 5 volts with a max current of 6.2 amps. What's interesting is that each port has its own current rating and is made for specific devices. The reason I'm looking inside this is it gets very hot when charging multiple devices. Before I do that, I will measure the efficiency of the charger by connecting load to its output. With the charger plugged into a power monitor, it shows 0 watts when nothing is connected to the charger. With a 3 amp load at 5 volts, the charger is using 19.8 watts from the wall. This makes the efficiency around 77%. With around 6.3 amps of load at 5 volts, the efficiency is around 76%. And after these short load tests, the charger was starting to get very slightly warm. With the efficiency test complete, let's see what's inside the USB charger. I removed all 4 screws and let's take a look inside. There's a heatsink cooling 2 devices and a smaller heatsink for the main switching transistor. There are also some capacitors, an LED, a bridge rectifier, even more capacitors, a fuse, and some interesting blue capacitors. There's even an NTC thermistor for limiting inrush current when the charger is plugged in. The charger also has an inductor and capacitor used for reducing electrical interference. The other side of the circuit board doesn't have much. Each USB output has resistors next to it to signal the current rating of the port using the data pins. There's a small control chip here that I think is for controlling the power supply. The 2 devices mounted on that one heatsink are actually diodes used for the DC output. On the front side of the board we also have the transformer, output capacitors, and inductor. This big capacitor is rated at 400 volts, 33 microfarads, and 105 degrees Celsius max temperature. The smaller capacitor is 10 microfarads, 400 volts. The output capacitors are 1000 microfarads, 16 volts. And this smaller capacitor is 470 microfarads, 16 volts. There's actually space on the board for 5 LEDs, 1 per port. However, only one of those spaces is used. There is a good distance separating the high voltage section from the low voltage output section. There are even slots cut in the board in 3 places for even better isolation. I find it a little surprising that this capacitor is bulging because I haven't used this charger much. It's mainly used while traveling. I think what's causing this capacitor to bulge is the heat generated by the other components in this charger. I noticed this extra label on the transformer showing that it is rated for 5 volts 6 amps, which is a bit less than the current rating of the charger. The designers are allowing the transformer to be overloaded a bit, which probably isn't good for it and could shorten its life. This small chip at the output is a TL431A. This is a voltage reference used for helping regulate the output voltage. But this is what is inside a 5-port USB charging station. I actually think the circuit is safe, but not the most efficient. In earlier tests, I found the efficiency to be around 75%. But anyways, make sure to subscribe for more videos.